Okay, so this is irrational functions and vertical asymptotes. So if we're talking about the domain of the function, all right, before in the past we talked about the domain as basically how far to the right and how far to the left a graph is covering. Now, in terms of this right here, all right, the easiest thing to do, instead of you telling me what x can be, it would be easier for you to tell me what x can't be. All right, so if we have a rational function, you're going to tell me the x values that would make the denominator 0. So when it comes to this, it's actually very simple. All you have to do is set the denominator equal to 0, and then you're going to solve for that. Anyway, after you do that, then what's x equal to if you solve for that? -2, right? So this would be x is equal to -2 if I subtract 2 from both sides. So it turns out the domain is all real numbers except for x cannot be equal to -2. All right, so just to kind of give you a quick example of what that would look like is if I have this right here, or if I have x minus 2 over x plus 2. Okay, notice that this graph does that kind of thing, right? So what that means is that x can be any number. Doesn't matter where you plug in for x, it'll give you a value back, except when you're trying to plug in a -2, which is right around this line right here, then it cannot give you a value. As a matter of fact, if you go to the table and you go to -2, notice that it says error right there. All right, so that's it. That's all you're doing for the domain. All right, so for the next few, that's all you're doing. All right, we're going to just set the denominator equal to 0, and we're going to solve for it. In this case, there's more than one way to solve that, but normally if I have one like this, I'd normally add the 4, take the square root. All right, so I have x squared is equal to 4, and if I take the square root of that, you would get not only 2, remember, you get plus or minus 2. So on this one, you actually have two parts, two x values that x cannot be equal to. Alright, so you can plug in any x value, and that'll give you a y value back except for negative and positive 2. Does that make sense so far? Alright, now, on this part right here, again, same thing, set the denominator equal to 0. And if I have that, if I take the square root, I still get a 0. So this is actually still x is equal to 0. This is all real numbers except for x cannot be equal to 0. So that's it for that. Now, on the bottom part, now we're talking about the vertical asymptote. A vertical asymptote is a vertical line, okay, in this case, that the x cannot be. All right, so if there is no common factors, then all you're going to do is set the denominator equal to 0. And in your case, at least for the first set of homework, you normally don't have to do that, right? So this is actually talking about example 1. It's asking you for where the vertical asymptote is at, and I actually already drew that. You see this vertical line right here? You can kind of see in green, hopefully. You see this line? That's where my vertical asymptote is going to be located. All right, so what that means as x gets closer and closer to the -1, sorry, to the -2, in this case, it goes up towards positive infinity. And in this case, as x gets closer and closer from this side to -2, it actually goes down to negative infinity. So, long story short, all you have to know, if you can figure out the domain on this, this is going to be very similar. The vertical asymptote is going to be at x is equal to -2. Right, x is equal to -2 is this vertical line that I drew right here. Right, and for the next one, assuming that you already try to factor and cancel, then it's going to be the same thing for the next one. X is equal to plus or minus 2, and then this one is going to be x is equal to 0. Notice that I'm not putting a not equal sign on there. They're going to be equal. Okay, so that's it for that. In terms of vertical asymptote and domain, sometimes they're going to be exactly the same, but in this homework that you have, they are going to be exactly the same, so you don't even have to worry about factoring the numerator necessarily. So on this one right here, again, set the denominator equal to 0, and then you're just going to solve for that. So this would be x is equal to, x cannot be equal to positive 1. It can be any number. Do you remember the all real number symbol, what that meant? All real numbers means it can be any x number. It can be any x number except for this one. Okay. Now in the vertical asymptotes, there's nothing I can cancel or anything like that, so this one's still going to be, this is going to be the same. X is equal to 1. Right, there's a vertical line at 1 that X cannot cross. Alright, on number 5. Alright, if you can quickly in your head picture factoring this. If you factor the top and the bottom, nothing's going to cancel, and that's a good thing. So again, I'm going to set the denominator equal to 0. And then I'm going to solve for that. Now remember, if I have a trinomial, right, with an x squared function, on this one is the one where I have to factor. And I have to think both of these are going to be positive. Remember, if this one's positive, that means they're the same sign, and that means they're both going to be positive. So factors of 3 that up to 4. 3 and 1, right? And then after that, we're going to set each factor equal to 0. This will be x is equal to -3. This will be x is equal to -1. Alright, so my domain is going to be all real numbers except for x cannot be equal to -3 or -1. Alright, so it cannot be equal to either one. Vertical asymptotes, they're going to be the same in this case. This is not always true, by the way, but in terms of your homework it is. Alright, on this one right here, set the denominator equal to 0. And this one, notice that this is the same problem as what I had in example 2, I believe. So if I have that, but I'm going to factor this time because I just feel like factoring. Right? So we're going to factor this into x plus 2, x minus 2. And then we're going to set each factor equal to 0. So I got x is equal to -2, x is equal to +2. Alright, so my domain is going to be equal to all real numbers except for x cannot be equal to positive or -2. And in this case, my vertical asymptotes are going to be x is equal to positive or -2. So this one actually has 2 vertical asymptotes, right? Now, real fast, I'm going to make up an example here for you. Then it's not on the homework, alright? So you don't have to worry about this, but I want to at least tell you this so you would know that this is not always the same. So for example, on this one right here, if I have something like this, let's say that I have +4 minus 1, I don't know, and this is x plus 4. Alright, so obviously this will be some kind of quadratic function, and this is that, right? Now my domain is going to be the same thing. Alright, my domain is going to be equal to all real numbers except for x cannot be equal to -4, right? So that doesn't change. You see why that is, right? If I set this equal to 0. So my domain x plus 4 is equal to 0. And if I subtract 4 from both sides, I get x is equal to -4, right? So that's why that can be. Now you would think that my vertical asymptotes are the same, right? You would think, well, the vertical asymptotes are going to be the same. Well, in this case, they're not. Okay, so look up here, Evie. I'm not doing this just for fun. Alright, so on this one right here, the vertical asymptote stuff. By the way, can I cancel this? I can I not? Couldn't I cancel this and this? Alright. So if I cancel this, what do you think this graph will look like on your calculator? Any ideas? Maybe I have a person that can just picture this. Alright, so let me show you what that would look like. Alright, so if I have something like that, so I have x plus 4, and put that in parentheses. I have an x plus 1, my x minus 1. And this is an x plus 4. Okay. Any bets what this is going to look like? Well, it turns out it looks like a line. Alright, so it looks exactly like a line. Alright. Do you think that's odd? By the way, look at that again. If I cancel this, what would I end up with? X minus 1, right? X minus 1. Isn't this the x minus 1 graph, if you remember how to use linear functions, right? It's crossing right through the y-intercept is negative 1. Now, so this graph right here, and x minus 1, they're exactly the same, except for one thing, that if you go to, in this case, negative 4, remember, which was this right here, you have an error. All right, so actually, even though your calculator cannot show you that, at negative 4, which is around here, you have a hole. So you have some kind of hole here. But my point is that this is not a vertical asymptote, though. So on this one, you don't have any vertical asymptotes. Kind of strange. All right, so anyway, this is what I showed you. On this one, it would be none. On that one, you wouldn't have any vertical asymptote because what it was, this right here, x plus 4 is equal to 0. If I solve for that, I get x is equal to negative 4. This is called a hole. So it looks just like the other one, but it's going to be a hole. Anyway, again, you don't have this last one on your homework. So on this homework, all you have to do is set the denominator equal to 0, solve it, and that will give you the domain, and that will give you the vertical asymptotes. That's all you have to do. Okay? Homework is due tomorrow at the beginning of class.